Okay, here's a solution for my version of number 25 on 642. I wanted you to not just find the intersections, but also graph these two things. And that gives us a really good guide as to whether the algebra is going to be correct for our when we do find the intersection. So the first one, x minus 2y equals 2, that's a straight line. So the straight line x minus 2y equals 2, we can just graph that by finding the intersections, finding the intercepts rather. If x equals 0, then minus 2y equals 2, and that gives you y equals minus 1. And if y equals 0, then x equals 2. Okay, so that's going to be a straight line with y-intercept minus 1 and x-intercept 2. And so it's going to have a positive slope 2. And let's just go ahead and let the computer graph that. And so there's the graph. Straight line. Okay, that's definitely not the hard one. This one is harder. And this is why I saved doing this section until after we had done stuff on conics, because this is a hyperbola. So let's do some algebra here. We need to collect everything on one side, or at least everything that's not a constant on one side. Let's leave the constant over there. The constants aren't too important. And we're going to have to complete the square. Okay, so really, really important. Careful with minus signs. I'm factoring out an overall minus sign, and that turns into a plus 2x. Now I need to complete the square inside that little x house. Put extra parentheses in. And x plus 1 squared would give you x squared plus 2x plus 1. So I kill off the 1 that I just added that I don't want. That is equal to 4. And now I can just collect the constants. Y squared minus the quantity x plus 1 squared equals, and let's be careful about this, this is a plus 1. And I'm going to subtract that off, and so it's going to be 3. A lot of people are getting 5 there because not being careful with the numbers. Okay, so, and now I just need to divide by 3 and put it in standard form. Y squared over 3 minus x plus 1 squared over 3 equals 1. And of course, if I want to, that can be written as root 3 squared, which seems silly, but that gives us our a and b. So notice it's plus y and minus x, so it's going to be opening up down. And a lot of people were missing that. Opening up down. A happens to equal b, equals root 3. And so, for example, that means that the asymptotes, which we can get out of the box anyway, but the asymptotes, we can also use the master formula, y equals plus or minus x, because b over a is 1. Okay. Oh, wait a minute. It's shifted. So it's whatever you see here, that's just y, plus or minus x plus 1. Everything has to get shifted. Every time you see your y or an x in a formula like this, it's got to get shifted. Okay, and the box will help us draw those as well. Okay, I don't think we really need the foci, because that's not too important to this problem. So we're going to draw the box. The corners of the box are going to be at, let's see, we're going to take the root 3's and just put plus or minuses on them, but we're also going to remember that we're going to shift everything left 1 in x. So it would be, let's see, so let's do the unshifted box and then we'll fix it. If we hadn't shifted it, we know we're just supposed to take this number plus or minus whatever under y, and there's the y variable, and this number, whatever's attached to x plus or minus, and is the x variable. And it doesn't matter so much for the box which one's called A and which one's called B. Now here they happen to be the same, so we're kind of lucky. We couldn't screw it up, even if we got those mixed up. But when you're doing the box, it's less about the letters and more about which variable is it under. So that would be just the 4 points plus or minus root 3 and plus or minus root 3. And so the actual box is going to be minus 1 plus or minus root 3 and plus or minus root 3. And those plus or minuses, I'm being a little cavalier. those are both independent of each other, so it's all 4 possibilities. Okay, so let's go ahead, and I'm just going to cheat a little bit and let the computer actually plot this just to be quicker. Okay, there's our up-down parabola, or hyperbola rather. It's really a hyperbola. And I'm going to go ahead, and there's a nice, let's see. Ooh, it's a little tricky to get. Oh, wait. I'm going to add an item here, and I'm just going to put in the asymptotes. I think if I make that a 1 and dot them. So I'm just kind of using a clever trick to put in the asymptotes, assuming I know how to be clever. Come on. There we go. Okay. So there's the asymptote. So the way that we would actually plot this, of course, is we'd put in the box and the vertices. Everything is shifted. So -1, we go up root 3 and down root 3. It's about 1.7, 1.8 to get the vertices. And then the box is we go root 3 over to here, 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 and here. So it's a little bit messy. You know, not everything's an integer or even a rational number. But the box is going to be these 4. Draw the asymptotes through the box, and then it's up-down hyperbola. And now let's add in, what was our other graph? It was x minus 2y equals 2. And see if we get an idea of where those intersections should be. X minus 2y equals 2. See if it takes as long to plot this out as it did last time. Okay. Looks like it should just come in. It's looking like it's actually just exactly tangent. That's interesting. Or maybe there's just 2 intersections that are really close to each other. So let's see what the algebra tells us. So that's finally done with the graphing. Now let's take this algebra. Let's just put it down below here. Okay, so the main technique here is substitution. And so we're going to have to either solve for y in terms of x or x in terms of y. Let's solve for x in terms of y. That first equation looks like it's maybe just slightly fewer fractions, 2 plus 2y. Okay, so then substituting in the second one, it's going to be 2 plus 2y quantity squared equals, and then 2 times 2 plus 2y, again, plus 4. Okay, so in this equation, we've substituted in x equals 2 plus 2y twice. And now we're just going to have to square everything out. So we get minus 4 minus 8y minus 4y squared. It's all minus because of the minus in front here. Equals 4 plus 4y plus 4. Okay, now let's collect it all on one side. We've got minus 3y squared, and then minus 12y, and minus 4, minus 4, minus 4, so minus 12 equals 0. There's a minus 3 that can come out of that, so that's very nice. Y squared plus 4y plus 4, aha, equals 0. That's a perfect square. That's just y plus 2 squared equals 0. So the only solution is y equals minus 2. And then, of course, we need to get x, and that's just 2 plus 2y. So 2 minus 4 is also minus 2. And that corresponds to what we're seeing here. Looks like right at minus 2 comma minus 2, we get a point of tangency. Typically, a line is going to intersect a hyperbola 2 places. You could either go here and here maybe, or it could intersect one branch here and one branch here, but that's a special case where it's actually tangent and it's just intersecting in this one point, xy equals minus 2, minus 2.